check.
Yep, working just fine. All right, so the first thing we'll do is to take a look at the schedule of classes for spring 2014. Because the next class most of you should be taking is cisp 360, and here is cisp 360. We basically only have 2 sections of cisp 360, and unless you're in priority 0, you probably have only one choice. Okay. Well, I guess since you only have one choice, it's not a choice anymore. your choice is to take it or not. You cannot choose which section. So this one is already closed as far as I know. Okay. The one taught by Subsidiary is already closed. But if you look at the schedule, this one is not the same as cisp 300 anymore. It's a 4-unit class. 3 units for the lecture and 1 unit for the lab, because in this class you actually have to write programs using a C++ programming environment. So that's why there's a lab component to this class, so that you can write your program in the lab and the professor can kind of overlook how you're doing and give you suggestions of what to do next. But if you look at the lecture time, it is broken up into 2 pieces. This is the first piece, which is only 40 minutes. Okay, but it has the same number of units as this class for lecture. So that means 1/2 of the lectures are quote-unquote online. So you will have to watch the video, you will have to read the textbook and do the studying on your own for the other half of the time. The lab time, which is also supposed to be 1 hour and 20 minutes, is also shortened to, well, in this case, half an hour. So that's really a small portion of the actual lab time, because it's supposed to have 1 hour and 20 minutes per meeting. If you have 2 meetings per week. So this is really just a small fraction, but it's already closed. This class is closed already. They cannot take on any additional people. So to most of you, this is your only option, which is the one taught by Damon Antos. And Damon Antos this one is a different arrangement, because it only has labs in person and all the lectures are online. So lectures are completely online, only the lab is in person. So in this case, you have 1 hour and 15 minutes. So that's a full duration of a lab. And then the other one is 1 hour and 10 minutes, which is also a full duration of lab. So this one has full duration for lab, but no face-to-face lecture at all. And, yep, go ahead.
Do you even have to really attend class?
That's up to the professor, to whether you have to attend the lab portion or not. Because he might give you quizzes during the lab time that has to be done face-to-face. Knowing Damon, I think that's what he's doing in his class. So you do have to attend the lab portion for the section that you are enrolled in.
Do you think there's any chance of them adding another section like this class? Because this was an added one too.
I think the chances would be pretty low. This class got added only because 3 of my other classes that I was supposed to teach, those were low enrolled, and they had to cancel those 3 classes. So those 3 classes got combined into one class, so we offer 1 extra cisp 300. So that's the situation right now with cisp 360. Most of you don't have a choice. Either you want to take it next semester, or you have to wait until some other time to take it. Yep.
Is there a way you can check how many spots are left in the classes?
How many
spots are left?
If you try to enroll, it will tell you.
I have it tomorrow at 8 o'clock. So, is there a way to check how many more spots left?
Yeah.
Just go to e-services.
Mm-hmm.
Well, there's also the outside version.
Yeah, you can check, but it's not going to help, because you even if you try to get in as soon as possible, the class may be closed already. So go ahead, do it as quickly as you can, but if it is closed, then you have to talk to either Professor Subsidiary or Damon Antos and see whether they will let you even sit in. Like, I let people sit in this class at the earlier part of the semester, but some professors may or may not let you do that. So you got to ask first. Yep.
What's an alternative to this class if some of us can't actually take it, so that we don't fall back or behind?
You can try a different campus, okay? Because what we are seeing is just this campus. So you can try out some of the other campuses. CRC, or Consumers River College, has a different policy. They offer more classes online. So if you look through their catalog, they might have CISP 360 online. Yep. That's interesting. They have Visual C++ instead of the usual C++. And this one is a hybrid class. It's done by Chapman. And it's also a hybrid class, so it's partially online. So you can check out the other campuses and see whether you can get into one of those sections. And because this one only has the lab face-to-face, you can talk to the professor and see whether it is mandatory or not. If it's not mandatory, then you can take most of your classes here and take that one online over there. But as a professor, I can tell you that in terms of teaching online classes is actually more difficult than teaching face-to-face classes. So I'm not sure, from the student's perspective, whether it's easier online or easier face-to-face. Does anyone have anything to say about that? Face-to-face versus online. Yep.
I agree. Online is harder.
It's harder.
Yeah, I tried it.
So online is harder.
You have to do everything. Like, you really got to read the whole book.
It's easier for me.
It's easier for you.
Yeah, because I just get the book and I get to be in my own face and do whatever I want.
Yeah.
Okay. Yeah.
I do like online because I type everything up in my homework like I do when I'm in the classroom or something.
Mm-hmm. If you have self-discipline and actually do the work, online classes is an option for some people. But face-to-face is more interactive. So when you have a question, it's easier to ask a question. And sometimes I don't even need to hear the question. I can see from the facial expression and go, okay, I'll go back and re-explain that. But with an online class, that is missing entirely. Some people read the textbook and not understand, and unless they ask something in the forum, the teacher, the professor never knows about those questions, because if you don't ask, there's no facial expression, you cannot raise your hand, and there's no indication whatsoever that there might be a problem. So there is that. And the next thing I want to do is to give you a little map of classes that you will be taking if you're going after a computer science transfer degree. How many people are going after a computer science transfer degree? So I would say about half the class. Okay. So this is cisp 300, which is a pre-programming class. That's the best way I would put it. The concept that we learned in this class is applicable to most programming languages. So it doesn't matter whether you want to program in PHP, C++, Perl, Java, and so on. Most of the concepts that we talk about in this class apply to most programming languages. The next class is CISP 360, which is basically a C++ class. So now we are starting to be more language specific. Okay, this is a particular programming language. Hopefully you will get all the actual programming concept in this class. So by the time you get to CISP 360, you only have to worry about the tools and the syntax of C++. But you don't have to worry about, what is a loop, what is a conditional statement, what is a variable, what is a parameter. All of those concepts, we've talked about it in this class already. After CISP 360, you start to branch out into two possible classes to take after that. One is CISP 310, which is Assembly Language Programming. And it does have a prerequisite of CISP 360. The good news is we used to offer CISP 310 only in spring, which means for most of you, you'll be missing it because you're taking CISP 360 in spring. But if CISP 310 is also only offered in spring, then you have to wait one semester before you take it. The good news is I think we are going to offer CISP 310 every semester now. So you won't have to wait one semester to take CISP 310 after 360. The other one goes in the opposite direction. It is CISP 400. CISP 400 is object-oriented programming. So we just say object-oriented programming using C++. The difference between 360 and 400 is 360 talks more about the language itself, the syntax. Okay, where do you put a semicolon? How do you use the open curly brace and close curly brace? CISP 400 focuses more on your program design. Okay, what is a class? How do you define the subclass? Why is that important? So it helps you structure your program so it's easier to maintain and easier to debug and easier to write. CISP 310 is assembly language programming. It allows you to take a look. It's kind of like giving you X-ray vision of your C programs or C++ programs. Without CISP 310, someone can write a program that is faulty in CISP 360 and never be able to explain the symptom of that program. Or based on the symptom of the program, never find out why it is problematic. So CISP 310 does allow someone to have that X-ray vision and be able to explain things that are really weird and be able to locate, oh, okay, if I see something this weird, it's probably because of a bug of this kind. Then you can start to look for it and be able to debug your program much more effectively than with only CISP 360. After CISP 400, you branch out again to CISP 430. 430 is data structure. And data structure talks about kind of more complex way of organizing information inside the program. Okay, so we'll start to talk about tree structures, binary search tree. They will talk about lists, doubly linked lists, and so on and so forth. That's CISP 430. And then we have CISP 440, which is discrete structure. I'll just say math, because that's what it is. If you look up the description, it is offered next semester, but you cannot take it next semester. So we are talking about, for most of you, these are the classes that you have to take. We are talking about fall 13 here, spring 14 here, fall 14, and then we are talking about spring 15 here. So ideally speaking, it will take you 3 additional semesters to finish all of these classes, assuming these classes are offered when you need it. Okay. But if you take a quick look at CISP 440, it does have a prerequisite of Math 370. What is Math 370? Pre-cal? Okay. The only reason why it requires pre-cal is to have a basic understanding of math concepts and what is a proof, what is algebra. So all of those concepts are important in CISP 440. It has a co-requisite of CISP 430, so that's why these two are kind of together, because 430 depends on 400. So that's why usually if you can, you take these two together. If not, you have to take CISP 430 first, and then you can take CISP 440. So for this semester, for spring, 430 is not offered. So yep, go ahead.
Can you do that same thing with the 310 and 400?
310 is on its own. Okay, as soon as you have taken CISP 360, you can take 310 anytime you want. And then same thing for 400. So those two are independent. You can take one first and then take the other one later. Like next semester is interesting because there will be a lot of people taking 400 and 310 in the same semester up here. And I'm teaching CISP 310. So those two can be considered somewhat heavy-duty programming classes. So you have to kind of look at your schedule. You don't want to take heavy-duty calculus or physics classes in the same semester because these two can take up quite a bit of time already. It depends. I mean, some people may look at these classes and say, well, it's not going to be too difficult. But in general, they are not considered lightweight classes.
What about the database class?
The database class has no prerequisite. So you can see the prerequisite is none, and it only has an advisory, 2 advisories of CISC 310, which is just an exposure to the computer industry, and CISA 320, and that would be,
Access.
that's Access? Okay. Which is a database class. But Access focuses more on the front end instead of the back end. And CISP 350 focuses more on the back end. So you'll be learning how to form queries using SQL and also learning the procedural language inside Oracle.
And notice that you didn't talk about 401 for the Java.
401 is only offered in fall. So that's why it's not.
And that wouldn't fall in the category to be on track with that, or no?
It would fall into here if you want CISP 401, it falls into here. So you still have to take CISP 360 first because Java shares, pretty much, the entire syntax of C++. But it is a different programming language. There are differences between C++ and Java. So CISP 401 will teach object-oriented programming, but only using Java and not using C++. But the natural progression is to take 400 before you take CISP 430. Okay. Are there any questions about the little roadmap here? And of course, check with your counselor. Okay, because I don't want to take, I don't want to do the job of a counselor, so I don't want to be held responsible for, what a counselor is supposed to do.
How did that one class fill up so quickly?
Which one?
Yeah, how did the one class fill up so quickly?
I can answer that. Many STEM majors are going to be transferring, and CISP 360 is required. And since we're transferring, we get 0.5 priority registration. So.
Oh, okay. So
we
that's
already
0.5.
signed.
Okay, so 0.5 is somewhere between a priority 0 and a priority 1.
Yeah. So we signed up the 27th of November.
Okay. And priority 1 opens up tomorrow. Is that right?
Between December 2nd and the 12th, 13th.
Okay, so within priority 1, there are different open dates too. Okay, so you are somewhere in the middle of priority 1. Okay, well, any other questions about, how to navigate through the computer science transfer degree? No questions? Okay, so based on, what the current plan, so this is my class, obviously, or one of the many people teaching that class. This is a tech exclusive class. And so is this one. So some of you will get to see me again, twice now. This used to be taught by Professor Fox, but since he's retiring, so I'm picking up CISP 440 from him. It's really kind of open. I said, to all the other professors, if they want to teach, those classes, they're more than welcome to. But nobody wants to teach CISP 440, so so it's me again. All right. So any other questions? No? Okay, but I do want to urge you to take CISP 360 right after this class. Unless you have some programming background already, then you won't have a problem. Otherwise, you will start to forget concepts that we learned in this class. That would not be the most effective way to take classes. Yep.
So you can skip 360?
Sorry?
So it's possible to skip 360?
No.
No, because it's a prerequisite to a lot of other.
Yeah, 360 is really important because they talk about the syntax of C++. Do you have programming, some kind of programming background in C++ already?
Yeah.
If you have taken classes already, or if you have industry exposure, and you think that you have to look up the description, okay? If you think you cover all of those topics already, you can file what we call a prerequisite challenge form, so that you can challenge the prerequisites of CISP 310 or the prerequisite of CISP 400, so you can get into those classes without having to take CISP 360 first. But your prerequisite challenge has to be approved by the department first So I don't know, who is going to evaluate your prerequisite challenge.
Do they give you the credits for the class? or-
No, they do not give you credit. They just simply means that you can take the next class, but you do not get a credit, which creates another problem, because if you want to get your transfer degree, you need the number of units. And not taking CISP 360 means you'll be 4 units short. So you still have a problem. You have to use another class to substitute for CISP 360 to make up for the unit count. And you have to look at the description of the course and talk to the professor and see whether your exposure to C++ is going to be sufficient. Because otherwise, if your exposure is not sufficient, then by the time you get to CISP 310 or CISP 400, you might realize and say, oh, these concepts I have never been exposed to. And at that time, it's going to be on you that you have to catch up with the rest of the class. So it may put you at a disadvantage at that point.
So here's a technical question. Does Professor Antos expose everything you need to know prior to 310? In your opinion?
The curriculum is already published, so he can disclose the curriculum of the class, so that way you know exactly what you need to learn in what you will be learning in CISP 360. So all the topics, all the student learning outcomes, are actually public information. Yep. All right. Any other questions? Yep.
As far as prerequisite, I know that SCC, Sacramento City College, CSP 301 is the prerequisite 301.
Yes, 301 typically should be considered equivalent to 300. So if you take CISP 301 from Sac City, you can usually take CISP 360 here, even though they are 2 different numbers. But that class is taught a little bit differently, so they put a different focus in programming. Okay. Those are all good questions. Any other questions? No? Okay. Yep.
370. CISP 370.
Is Visual Basic Programming. CISP 370 does not substitute CISP 360. In other words, it doesn't really help you in getting the transfer degree in computer science.
But is it a substitute for 300?
It is. It can be a substitute for 300. Have you taken that class already?
Yeah.
No?
I'm just curious.
I have heard people who have taken CISP 370, and in my current CISP 300 class, those 2 classes are very complementary. CISP 370 is very pragmatic. You actually start to program in Visual Basic. You put buttons on your form. You do all kinds of fun stuff, but they don't focus much on the theory of computer science or programming. So it's very hands-on, but it doesn't have enough of the theoretical part. This class is very dry. It's all theoretical. We don't actually write programs that can run, but you understand all the basic concepts in programming in this class in details. So those 2 classes, they're really good together. If you take both, you can use CISP 370 to substitute for CISP 300 in some cases. Any other questions? Looks like you have a question.
Yeah.
Go ahead.
I know someone who took CISP 440. That's discrete mathematics, right?
Yeah.
Okay, so he took it in LA.
Okay.
He has no other prereq, like he doesn't have 300 or 360. Is that considered a prereq for any of the other classes?
That is a strange one, because CISP 440 is more of a math class than a programming class. So passing CISP 440 does not necessarily mean that that person has enough programming background for the other classes. If in doubt, go ahead and file the prerequisite challenge form anyway, because the worst that can happen is it's not approved.
Okay.
Yep. But 440 is definitely a math class. If you look at the description of the class, it includes elementary formal logic, which we cover a little bit in this class, We don't talk about set theory in this class, but in that class, it will be at least touched on. Combinatorics, recursive programming, which we talk about in this class. Algorithm analysis. We don't really do much algorithm analysis in this class, not formally. Finite state machines, it's really kind of dry, but it's actually very essential to a computer science degree. Formal languages are also related to finite state machines, kind of dry and formal and theoretical kind of stuff. Digital logic and switching, that's really helpful to people who want to get a computer engineering degree in the end, because that's really the stuff that goes inside a processor or most of the digital processing devices. Recursive and then we have circuits and computer arithmetic. So it's really just everything that does not that is not programming, that's math, is kind of thrown into that class. It's kind of like a mixture of all of that stuff. All right. So if there are no questions about that, let's go ahead and continue with this class. Are there any questions about the homework assignment? Remember, we got a homework assignment assigned on Tuesday that has the confusing return statement that has an invoke inside. Okay. Are there any questions about that one? No? Nobody has started yet? You have started? Okay. Okay. Yep, go ahead.
The area, the thing you had the other day in the demonstration program, is it I think the same ones in the homework. Like it says, it says to do this to do this thing using the value of itself. So it's like A to A. Is that an error or is that intentional?
A to A. Let me bring that up so we can actually look at it and then talk about it. That's in topic 7. And close to the end. Okay, so we are talking about sub 2. Okay, which line are we talking about?
24, I think it was.
Say again?
I think it was 24.
Line 24. No, that's not a typo.
Oh, that's not?
It's referring to array A here. So that A, which is a local variable, is what we use to specify parameter A. So the two A's are different because the one A to the left-hand side is the A that belongs to this subroutine, and then the A on the right-hand side refers to the parameter of the subroutine that you're calling, that you're invoking. So those two A's are not the same, they're distinct. Which is actually the same concept on the other line here. On this line, it's the same thing. Because when you look at these two A's here, this A refers to parameter A of subroutine traverse, which is referring to the parameter of the current invocation. The other A is referring to parameter A of traverse again, but this is the invocation that we are setting up, that we are going into. So those two A's, once again, are distinct. One is my parameter, and the other one is the parameter of the subroutine that I'm invoking. Okay. Any other questions? No other questions? Okay. If there are no other questions, I will go back and continue with the exam 2 questions. So we basically want to clear that first. And let me just borrow it from the other class. I just never... Yep, go ahead.
Do you anticipate it being graded prior to finals?
Yes. Okay. The final exam for this class is on the 17th? Okay.
Is the final exam going to kind of be a collection of everything, or just what we've most recently talked about?
It is comprehensive. The final exam is comprehensive, and you are guaranteed to have at least one pre and post condition question. All right, so we covered question number 1 already, and today we'll start with question number 2. This is from a different class, so the actual numbers may be a little bit different, but it's really the same kind of question, so I can just borrow it from the other class. So what I'll do is I'm going to copy and paste this into a spreadsheet, so that way we can trace it in this class a little bit more easily. So let me get rid of the other one first. Oh, I just closed the one that I did not want to close. That's okay. Just open it again. There we go. Yeah, question 2 is, I would say question 2 is one of the easier questions. The binary search one is a little bit harder, I think. It requires a little bit more analysis. Trace. So now we have 2 windows open. One to look at the algorithm, and the other one to look at the trace. All right. So are there any questions about the algorithm itself before we get started, or questions about the trace before we get started here? It's a partial trace, which means something has been done already to get up to this point. So the next question is, the question asks you to continue the trace until the first time you execute line 7. That was the question. Okay, so let's go ahead and say, okay, where are we at this point? We are on line 2 at this point, and one return line number column has been set up already, which makes sense because fx is a subroutine. So somebody has to invoke sub x for my current line to be on line 2, and that's why your column D is already used for a return line number. And from the way it's set up, where we came from. We came from line 9 in order to have a return line number of post. After line 2, we go to line 3. Line 3 has to evaluate the condition of 4. 4 is less than, n is less than 4. N has a value of 3. 3 is less than 4 is true. Okay, so we go into the subroutine on line 4. Line 4 invokes fx again, which means we have to allocate the leftmost available column, in this case it's column E, and indicate which line we have to go back to when that invocation of fx is done. So what should I put here in column E? 5. Okay, if that makes sense. And then after that, we get into the subroutine that we are invoking, which turns out to be fx. The first line in fx that we trace is on line 2. And on line 2, we add 1 to n. N goes from 3 to 4. Then we go to line 3. We compare n to 4. N is less than 4 is now false, because 4 is less than 4 is false. Okay. Where do we go next, since the condition is false? We go to line 7. Line 7 is the end of the subroutine, which means we go to the rightmost return line number, and we say, oh, it's telling me to continue execution on line 5. We have to make a note of that first, and then we can deallocate that particular column. And that's it. That's all that I'm expecting, for the answer of this question. So are there any questions about this one? Okay. This one is I would say this one is fairly straightforward. It's really just, tracing it until we get to the first time we get to line 7, finish what line 7 is supposed to do, and that's it. Now, if anyone continues and say, oh, on line 5, we have to subtract 1 from n and turn it back into 3, I'm not going to take off any points because, I only ask that you trace up to line 7, but if you want to trace, further than that, no harm is done. It's just wasting a little bit of your time in that case. Okay, so that's question number 2. Move on to question number 3. Question number 3, I was hoping that it is a simple one, but it didn't turn out to be a simple one for people who do not remember what mod was. And I could not tell you what mod was during the test because that's actually what I'm testing. So that was kind of unfortunate. I will see if I can give you partial credit, based on what you turn in, in the trace. But this is a little bit hard to assign partial credit. So
when did you teach on mod?
When we worked on the algorithm to factor out numbers. when we talked about top-down design, we worked on the program that factors a number into all of its prime components. And inside the subroutine or inside the statement, find prime number f of n, it needed to use mod to see whether f is a factor of n.
So like one time, probably.
Well, it's in the notes. I mean, it's open book, open notes, man. If you it's open book, open notes. So I don't know.
I just took a shot in the dark and figured to put it out of the array, and I just marked that out.
So I can expect to see some creative solutions to this one. All right, so let's go ahead and take a look at this one. All right, and we have the algorithm on the left-hand side, the trace on the right-hand side. Line 1, I gets a value of 2. Line 3, a bracket I gets the value of I. So I'm hoping that everybody at least get to this point, right?
Oh yeah.
Because if someone cannot get to this particular line, that's really bad, because you only need to understand what an assignment statement is, what a repeat until statement is, because you have to perform one iteration before you check for the exit condition, and just array indexing. So this one, I'm hoping that most people would get. I'll just assign some partial credit to this step, okay? But remember, I didn't say how many, how much. Okay, but line 4 is really the magical line, because that's what I'm testing is, can you figure out what is the new value of I? Mod is the remainder, okay? So when you say I plus 5 mod 4, it means the remainder of I plus 5, the whole thing divided by 4. In this case, I has a value of 2. 2 plus 5 is 7. 7 divided by 4 has a remainder of 3. That's right. So I becomes 3. And then we get to line 5. It has to evaluate I equals 2 is false, okay? Because I now has a value of 3. Then we go back to line 3, and we go to a bracket 3, change its value to 3. Go to line 4 again. So this time we have 3 plus 5, which is 8. 8 mod 4 is 0, because the remainder of 8 divided by 4 is 0. So I becomes 0. And then we go to line 5. I equals 2 is once again false. Then we go to line 3 again. So this time we go to a bracket 0, change its value to 0. Then we go to line 4. And this time we have 0 plus 5, which is 5. 5 mod 4 is 1. Okay. So I becomes 1. We go to line 5 again. I equals 2 is false. We go to line 3. A bracket 1 now gets a value of 1. We move on to line 4, and it becomes 1 plus 5, which is 6. 6 divided by 4 has a remainder of 2. All right. So we know we are close to being done. I equals 2 is true, and then we get the post, and we are all done. Yep.
We deduct points if we skip line 5. We didn't evaluate it. We just assumed it was false until it was true.
Well, how did I trace algorithms like this in class? I always trace line 5. So line 5 is important. It is important because I need to see the comments when you trace line 5, so that that explains why it is going to line 3 instead of going to post. So that is actually important. It has the significance of telling me that you understand, oh, this is a decision point based on the condition. We go one way or the other way, or which condition leads you to this way or the other way. So that's why it is important.
And I did signify that it was true on the very last
Okay, well, I will have to take a look at what you wrote down to see, how I will mark it. Okay, any other questions? No other questions? All right, so let's move on to the next one. Question number 4. Question number 4 is my favorite because, I think it really tests, whether you understand or whether you can analyze an algorithm or not. Okay. Well, it has 2 parts. Okay. So once again, this one definitely has partial credit. For people who do not get the first part or know what kind of value for k will lead you to this state, as long as you trace it, the rest of it correctly, you will still get some partial credit. Okay. So this one does have independent partial credit built into it. So once again, I'm going to use a new spreadsheet to show you how to solve this one. I can just reuse this one and use sheet 3 for the algorithm, which is a binary search, but it's the recursive version of that. And then we have the trace that's already partially done. And we'll get into the other one. Uh-oh. Okay, there we go. We get sheet 4. And this one is a little bit longer, so I'm going to have to reserve more space for comments. But the other columns can take up less space. Still need to zoom out a little bit. I just did it this morning, so I know it won't fit on the screen unless I change the zoom. So, and then even this one has to be zoomed out a little bit. Okay, maybe one notch. One more notch. There we go. All right. So the first thing, well, not the first, but it would be helpful to do that first. The first question is, what kind of value for k will get me to this state? In other words, k has to be initialized before the program executes. The question is, what kind of value should I be looking for in order for the algorithm to get to this point? And by the way, different versions of the test will have different values for the elements in A, but because B and E are still the same across all the versions, so the way you find a value to get to this point should still be the same. Okay, so let's go ahead and analyze the binary search algorithm and take a look at our current state right now. We are currently on line 9. So we are here in the algorithm. So we have just gone through all of this stuff here. And as a result of that, B now has a value of 2, E has a value of 1, and M has a value of 2 also. Okay, that all by itself, okay, if you just look at these 3 variables, that gives you a hint of how we got to this point, right? Because in order to get to this point, the previous point or the previous state has to be B and E being the same. Does that make any sense? Okay, let's reverse the steps a little bit and see how we can get here. Okay, we are currently on line 9, okay? And I'm already telling you that not found and B is less than or equal to E is false because, well, found itself is false. That's already enough reason why the conjunction is false. Now, if found is false, what is that telling you about A bracket M and K, the relationship between A bracket M and K at this point? They cannot be the same, right? Okay, so we know A bracket M using the current value of M, which is 2, cannot be the same as K. So we know that K cannot be 7. That part we know for sure. Okay. What else do we know? Well, we also know one thing, because in order to get to this point, we know that it has to gone through either line 4 or line 6. Now, how do I know that? Just knowing that A bracket M does not equal to K, how can I immediately make the deduction that either line 4 or line 6 has to execute? Pick one. Okay, at this point, I don't even care which one, but I know at least one executed. That's because if you look at the condition of line 3 versus the condition on line 5, one will be true when A bracket M is less than K. The other one will be true when A bracket M is greater than K. Well, I just deduced by line 8, or the result of line 8, that A bracket M does not equal to K. So it has to be either less than or greater than. So I know that I get to this point either through line 4 of the conditional statement or line 6 of the conditional statement. So I know that much for sure. So the next question is, but which one did I actually use to get here? In other words, did I bump B up by 1 or bump up B to M plus 1 in order to get to here? Or did I bump E down to M minus 1 to get to line 9? That is the next question. Okay? What do you think? Well, E is not supposed to be less than, or E is not supposed to be less than B. So the fact that it is less than B at this point has to be the doing of the conditional statement that I just went through. So that means because of that, because E is 1, I know that it must have gotten the value of 1 through line 6. Okay? And because it went through line 6, I know that A bracket M is greater than K. So that means J, column J, which has a value of 7, has to be greater than the value that I'm looking for, which is K. Is that making any sense? But I also know that it has to be greater than 5, because otherwise I wouldn't be ended up in this state either. Because at this point, it has already eliminated column I or A bracket 1 as a potential. So if it is not greater than 5, I would not have eliminated that possibility. So that's why I know it is somewhere between 5 and 7. So if you pick any value for this particular example, if you pick any value between 5 and 7, not including 5 and 7, it is considered a correct answer. 6, for instance, is one correct answer in this case. Is that making any sense? Sort of? Okay, so in this case, I'm just going to pick 6, but if you say 5.1, it works. 5.01 works. 6.99 works. So anything between 5 and 7, excluding 5 and 7 themselves, would work.
What were the values for the array in our exam? I know that it was 15 for K, right?
15?
No, the A0, A1, A2, A3. What were the values in our exam?
I cannot remember. There are 4 different versions in this class too. Yep.
I think it's the same.
Hmm?
I think this is the same.
So you got the same one here?
No.
Mine was,
There's a 15 and 13.
I made sure that there are integers in between, so you don't have to resort to fractional numbers. So I don't think anyone will see like 1, 2, 3, 4. There are no consecutive integers. So I make sure that there are integers in between. So you don't have to say, oh, but you didn't tell me this can be a fractional number. So because there is an integer in between too. Okay, but this is only a part of it. The second part of the question is to finish the trace, finish the entire trace. And this is where some people may look at the algorithm and go like, oh, no, this is going to take a long time to do it. Well, let's go ahead and do it and see how long it takes. We are already on line 9 at this point, and the condition is already false. So line 9 is completely done. We can now move on. Where do we go now that we know the condition is false? We go to line 12, exactly. Okay, so we go to line 12 here, and line 12 is the end of a subroutine. What do we do at the end of a subroutine? 2 things to do. Look up the rightmost return line number, which is column M in this case. Make a note of where we are supposed to go. Oh, it's line 12 again. It's okay. If it tells you to go to line 12, make a note and forget about it. And then we deallocate the column. So this has to be included in your answer is the deallocation of the column, because that is also important. Then we continue execution on line 12. Well, line 12 is, once again, and define sub, so we locate the rightmost return line number. In this case, it's column L, because column M is now deallocated. It tells me to continue execution at post. Make a note, and once again, deallocate this column. And then we move on and actually continue our execution based on the line number. But post indicates that we are already at the end of the entire program, so we're done. So the second part of the question actually takes very little time to execute, despite the algorithm looking kind of nasty. All right, so are there any questions about this one? This is question number 4.
Yeah, why wouldn't you get a line 10 after line 9?
Because the condition of the conditional statement is false. You only execute the then branch when the condition of the conditional statement is true. So that's why we don't go there, right? It is false for 2 different reasons. Well, actually, for only one reason. I take it back. There's only one reason why it is false. Found is false, not found is true. So the left-hand side, I'm correcting myself from earlier. So not found is actually true. I have to evaluate the second one. B is less than or equal to E is actually false, and that's why the entire expression is false. All right, so now that this part is done, let's move on to the last question. The last question was not, well, the AM class got the nasty version of this one. You guys got the easy one. Yeah, the AM class got the really curveball version of this test. So this is, by comparison, the one that you guys got is not quite as bad as the AM class. All right, so we'll go take a look anyway. And, it doesn't need that much space. I'm just copying and pasting it anyway. All right, so here's the algorithm, and here is your partial trace. We need more space for comments because the expression is kind of long. And then we want to shrink the other columns so they all display at the same time. All right, so the question is telling you there's a problem here. Okay, that's the first thing. There's a problem here. And I want to put a value into A bracket 1 so that the problem would actually show up. Okay, so when you trace it, eventually we get into a problem and go like, hey, this is not good. Okay, so let's go back to the question first, just to make sure that I read my own question correctly. Okay, figure out, okay, there you go. The following pseudocode has a problem. However, the bug does not show in every test case. So you can basically make a test case where the problem does not show up at all. Figure out what the problem is. Complete the precondition of the following trace, which means to figure out what is A bracket 1. And it's spelled out here. Fill in the value of A bracket 1 and trace it until the problem happens. Be sure to comment somewhere what you think the problem is. Note that the problem may or may not be properly caught and reported depending on the programming language and environment. That is a hint already of what the problem may be, right? An infinite loop is an infinite loop. Okay, it doesn't matter whether it's C++, PHP, Java, Perl, PHP, and or Python. An infinite loop is still stuck in an infinite loop. What kind of problem depends on the programming language that we have talked about in this class?
Out of bounds.
Indexing an array out of bound. All right. So that means when you analyze the algorithm, you can now focus on only certain parts of the algorithm. In other words, there are only 2 places where indexing happens. One is on line 4, and the other one is on line 5. So now you have, and both of these are inside the loop. Okay? So when I say sometimes it happens, sometimes it doesn't happen, it means sometimes the loop will exit before it gets to the problematic line, and other times you can actually get to that point. Okay, so knowing that, the next thing you have to do is to look at this algorithm and say, Okay, so let's take a look at the precondition here. And this your version is not like this. Your version looks like this.
It had
And that's
35.
why it's easier. Huh?
It had 35 instead of 20.
Yeah, you have a different value for the comparison. And depending on which version of the test you get, there are 4 different versions too. Okay, so in this case, we have 20 here, but the operator between is an OR, which means either one can make the condition true. Okay, and then you stay in the loop. Well, that makes things a whole lot easier, doesn't it? The AND one is actually difficult. There are cases where it is impossible to make it fail. The rest of the program is also different. I'm trying to remember what it looks like in your version. Does anyone remember? I think it doesn't have this line here. That's what. Yeah, that's it. I think your version is just that, without the line in between. Yeah. Okay, so your version looks like this, which means it is entirely dependent on the value of the element in the array to determine whether you can step into that problem or not. Okay, so knowing this, so you only have one single line that can cause a problem. So the question is, how can this line cause a problem? Well, indexing out of bound. But how can you be here and still be indexing out of bound? Isn't this condition supposed to guard that from happening? Because I is less than bar A bar will guarantee. If I is less than bar A bar, and since I started with a value of 0, that kind of guarantees that I is a valid index. But what can, because of the OR, right? So as long as the variable sum, or S has a value that is less than 20, it makes the entire disjunction true. And as long as the disjunction is true, you will continue to execute the body of the loop. So what you need to do is to make sure that the sum stays less than 20 until you have the out of bound condition to happen. That's all you need to do. And in this particular case, I gave you, 2 out of the 3 values. You just have to make sure that the summation of everything is less than 20. So if you don't want to use a calculator to actually calculate the value and whatnot, just pick a huge number that on the negative side.
I think
right?
ours was 15.
Huh? Oh, in this case, picking anything up to, no, it doesn't even have to be negative. In this case, anything up to and including 4 will work for integers. Okay, if you want to specify fractional numbers, you can specify anything up to 5, up to but excluding 5. That will work as well.
Ours has a condition of 15.
Yeah, there are 4 versions.
Would be like,
Yeah, I think in your case, the summation of the given numbers is already exceeding that, so you have to specify a negative number.
Yeah.
And a few people walked up to me and asked me, can I use a negative number? Yeah, sure. Okay, but in this case, just specify a huge negative number. I didn't ask you about the largest value that will still make it fail. I just asked for a value that will make it fail. If anyone gives me like negative infinity, I would probably still count it in and say, yeah, okay, we'll let this one pass. Because you understand the concept, okay? It's just the concept that is important. Okay, so now we have the trace here. So line 1 initializes I to 0. Line 2 initializes the sum to 0. Line 3 has to evaluate S is less than 20, which is true. So using the short-circuited evaluation method, I'm just going to say S is less than 20 is true. Because with a disjunction, if one side is true, the entire thing has to be true, and there's no need to evaluate the other side. Okay? And then we go to line 4. Line 4 says, we want to compute the sum of 0 and 7 in this case, and that is 7 itself. We move on to line 6. I didn't bother to renumber the lines, that's why it's line 6 here. I gets I plus 1. Okay. We go back to line 3. Sum at this point is 7. 7 is less than 20 is true. so I don't even bother to evaluate the other side of the disjunction. Move on to line 4. This time I'm adding negative 1,000 to 7, so that makes it 993. Oh, I have to put the number here first. Negative 993. Change the width of the column. And then we move on to line 6 again. We add 1 to I, and then we go to line 3 again. Same thing. Line 4. We're adding 8 to negative 993, so that will make it negative 985. I could have just used this method, which is more reliable, right? But not in your test because you have a paper test. And then on line 6, we add 1 to it, becomes 3. We go back to line 3. The problem doesn't happen here. This is not the problem. So you have to wait until we get to line 4. Then we have a problem, and just explain that it's trying to index out of bound because array A only has 3 elements, and I'm trying to index the 4th one at this point. Okay. Are there any questions about this particular question? Indexing an array out of bound is really bad because in this particular case, I will end up reading the content of some memory location that is not a part of array A, which is fairly benign. Okay, it doesn't cause the program to crash. It doesn't really. It will just do the wrong thing. Okay, it just doesn't exit the loop when it's supposed to. But in some other cases, it can corrupt memory, and depending on which part of memory is corrupted, your program can behave in a way that cannot be explained. Okay, so when you move on to cisp360 and you start to deal with arrays and you are accessing or overwriting elements in an array out of bound, you can cause a problem where the symptom cannot be explained. In other words, you can have a problem like you have main here. Main is invoking, let's say, subroutine F. Okay, but when subroutine F returns, it returns right into subroutine G, which you never use at all in your program. That can happen when you overwrite an array out of bound in C++. Okay, I'm only telling you this because that problem can only be explained when you take CISP310. So that's one reason why CISP310 is useful, is because it gives you the additional knowledge that you need in order to fix programs that might otherwise be unexplainable. Okay. All right, so those are the 5 questions that we've gone through in the test. I have not finished grading yet, so I'll basically have to take a look at the distribution and find out how the whole class perform in this particular test. How do you guys feel about this test?
Feel better now.
Feeling better now.
Yeah.
After it's over.
Sorry?
It's like after it's over.
Oh, after it's over? Well, there's still the final exam, which is 40% of your entire grade. And as I said, you only need 37.5% to pass this class with a C. And the final exam is 40% already. So that's still hope for everybody. I throw in some analytical questions in this particular test because I just want to see how it works out in this case. Yep.
So what if instead of an or, there was an and?
If it's an and, then it depends a lot on if it's an and, then you have it won't fail. It's impossible to fail, because if this is an and instead of an or, that means both of these conditions have to be true for the entire thing to be true. So you can have this condition here, but since I is less than bar a bar, will become false when I is 3. That will turn the entire conjunction false, and as a result, you will get out of the loop, and you won't have a chance to evaluate the array indexing operator on line 4 at all, when I is no longer a valid index.
The other class had this question, right?
The other class has this question, but they also have something else, which is the line that I deleted. Yep. Okay. Any other questions? Yep.
The last one, 0 does work.
Even for this one?
Yeah.
For this particular one, yes, 0 would work. You know, anything that is less than 5 would work in this case. But in your test, you know, if I give you 7 and 8 here, I would have given you like 14 here. So you will still have to pick a negative number for the problem to show up. All right. Any other question? Yep.
I was going to say, I actually remember what the question was. It was like 17 and 18, and that was actually 34 or something like that.
It was 35.
35.
Yeah, I make it just barely not quite meet the requirement. So you have to figure out, okay, how do I nudge it to make that problem happen?
Yeah.
Yep. All right. Well, with the remaining 10, 12 minutes or so, I'm going to give you another example, not for the exam. You know, we'll do the exam review next week. You know, 1 week before the actual final exam, I'll give you a mock final. But right now, I'm going to give you another example of subroutines. This one is kind of interesting. I'll call this post-inc, okay, post-increment. And it will have a pass by reference parameter. I'll just call it x here. X gets x plus 1. And it will also return a value, and it's going to return a value of x minus 1. And define sub. All right, so here is the subroutine. Once again, it is a combination of things that we have learned already in this class. It has a weird combination that normally people think, well, we only need to use one or the other. Why are we using both in this case? Passing by reference is one way to pass a result back to the code that is invoking the subroutine. But returning a value is kind of the same thing too, right? I mean, you're basically passing a value back to the code that is invoking this code. This is combining the two in a kind of weird way, because I'm returning x minus 1, which is the old value of x before I added 1 to it. So what is the whole point of doing this? It's called post-increment, okay? As it turns out, this is a common operator used in C++ and Java and any language that are derived from C++. In C++, the interesting thing is, if you want to post increment I, you just say I plus plus, and that will basically be equivalent to invoking post inc on I. And that's actually how C++ got its name. Because there's originally C, and then the enhanced version of C becomes C++, because it is one step better than the original C. And then how it became C# in Microsoft's case, I don't know. I think it's just someone is musical, for instance, you know, they want to say, oh, C# is one note or one semitone higher than C. That can be one explanation. The other explanation is just bad penmanship. Someone wrote the two pluses overlapping each other, and then the supervisor said, oh, C#, cool name, we'll just use that. Right? All right, so let's take a look at this particular thing and see what it's going to do. I will define a subroutine. Oh, I forgot the sub part here, so I'm going to, just to be more consistent. In pseudocode, it really doesn't matter. Define sub main, and we need a local variable in this case. We'll just call the local variable I in this case, and then we'll do something. Trying to think of something to do. Let's do this. Print, invoke, post, increment, using I to specify x, and then we'll do it again. Okay, so we have two invocations of post increment. Both are using I, and we'll try to figure out what this code is going to print. And define sub, invoke main. There we go. So that's our entire algorithm. And then we'll go ahead and trace it. This one actually is quite relevant to C++, because post increment is a very commonly used operator in C++. Oops. Let's go ahead and define. There's no need for comments except for that line that prints something. So we'll reserve a column, but we don't really need to pay attention to it until much later. We have line number. There are no global variables in this case, so precondition really has nothing to say. Then we start execution on line 10. Main does not return a value, so we just say return line number is post, because there are no additional lines to execute after line 10. We also need to reserve one column for local variable I. Every local variable, including elements inside an array, should start with unknown values. So the question mark represents the unknown value. And I forgot one additional line here, because otherwise it doesn't make sense. So I need to start with a particular value. We'll just make it start with 0. And we'll make this line 7.5. So now we start execution on line 7.5. I gets a value of 0. I is a local variable. And then we move on to line 8. All right. So this is a combination of things, but at this point, I don't really even care about the passing by reference part, because I know that there are 1, 2, 3, 4 things to do in this case. The last thing I want to do on line 8 is the print. Okay, I want to print some kind of value to the screen or on a piece of paper. The second last thing I want to do is the addition, right? Because it's the sum that I want to print to the screen or a piece of paper. The first two things I have to do is to figure out what are the return values of the two invocations to post inc. Is that making any sense? Okay. And by convention, I'm just going to go from left to right, so I'll take care of the left one first. So we need a return info in this case, because once we come back from post inc, I have additional things to do on this line. So that's why we use a return info. And when we come back, we'll be going back to line 8. The print part has not been done. The first invocation will be done. I have a single value at that point. The second invocation is not done yet, so I have to finish that one after I come back from this invocation. So that's how I would write down return info in this case. Now it is, yep, go ahead.
Does it matter which one you start with?
In this case, it does not. Now, if this is a conjunction or a disjunction, then it matters, because short-circuited evaluation dictates that it has to go from left to right. In the case of addition or multiplication or any one of the other arithmetic operations, it does not actually matter. The C compiler sometimes will actually reverse the order. In other words, it will go from right to left depending on how the compiler is written. But the programming language does not indicate which order is the correct order. But just by convention, because we read from left to right, I follow that convention here. Okay. And we need one extra column to represent the parameter. In this case, we have parameter x, which is passed by reference. I am using I to specify x here, and local variable I is occupying column D. So that means x as a parameter passed by reference is an alias of exactly the same column. So x is also known as column D, because it is basically the same thing. Are we doing okay so far with this code? Okay. And I can just extend this out a little bit here. Now that we get into the subroutine post inc, we'll start on line 3. Line 3, the first thing it does is to add 1 to x. X is also known as column D. Column D has a value of 0. 0 plus 1 is 1. I'm going to store that back into x. X is also known as column D. So column D is actually modified right away, and it has a value of 1. Then we move on to line 4. Line 4 is a return statement. It's returning x minus 1. So we have to figure out what is x first. X is also known as column D. Column D now has a value of 1. 1 minus 1 is 0. We are returning a value of 0. Okay. To return a value of 0 means we have to locate the rightmost return info cell, copy and paste it, change the question mark to the value that we are returning. In this case, it is 0, and we're done. Then we move on to line 5. Line 5 is the end of a subroutine. We got 2 things to do. One is to make a note based on return info, where we are going back and what else we have to do on that line. And then the second thing we have to do is to deallocate the columns that were allocated earlier for this particular invocation. So in this case, we have 2 columns to deallocate, and then once we are done with that, we can now continue execution on line 8 again. Line 8 now looks like this. Print 0 plus invoke post inc plus using I to specify x. So now we have to perform the second invocation of post increment. Okay, so we have to do exactly the same thing. Allocate 1 column for return info. I'm reallocating column E because it is now deallocated. It is free. It becomes the leftmost available column. But what I write here is I have to go back to line 8. The first invocation is already resolved to a single value of 0 at this point. I keep that result here. The second invocation is what I'm dealing with at this point. So that's why the second invocation, or the one to the right-hand side of the addition, is the one that is replaced by a single question mark, because I just need a place. I need a placeholder for its value. That's why we have a question mark. It has 1 parameter, which is x. X, just like in the first case, is specified by local variable I. Local variable I is column D, so that's why x as a passed by reference parameter is still an alias of column D. Are we still doing okay at this point? Okay. Now we move on into the subroutine. Oh, this is off by 1. There we go. So now we continue execution in the subroutine starting on line 3. Line 3, it will add 1 to x. X is also known as column D. Column D currently has a value of 1. 1 plus 1 is 2, so now we store 2 back into column D. So column D is now updated to a value of 2. Are we doing okay so far? So you can see how the first invocation is actually affecting the second invocation in this case. So now we move on from line 3 to line 4. Line 4 is a return statement. It says it's saying return x minus 1. X is also known as column D. Column D now has a value of 2. But we are not returning 2, we're returning 2 minus 1, which is 1. So now we are going to here, copy and paste it, and change the question mark to the value that we are returning, which is 1. But we don't change 0 plus 1 to 1 because this is not the right time to evaluate the addition. We are just changing the question mark. And now we move on from line 4 to line 5, which is the end of the subroutine. Got 2 things to do. Locate the rightmost return info cell, copy and paste it, make a note of where we are supposed to go after this, and then we have no use of these 2 columns anymore. Indicate that they are now deallocated. And now we continue execution on line 8 again. But this time on line 8, we have everything done already. We know what is 0, we know what is 1, we know how to add. So we have 0 plus 1, which is 1, and we know exactly that is what we are printing. We print a single value of 1, and we are done with line 8. We move on to line 9, which is looking up the rightmost return line number. It's column C. It tells us to continue execution at post, and then we have no use of column C and column D anymore. Indicate those are now deallocated, and then we are done. Okay. So with this one is actually relevant to the next class that you're going to take in cisp360, because the plus plus operator, having the plus plus after the variable is post increment, and that's exactly what it does. All right. Well, we went over 1 minute, so I'll see you guys next Tuesday. Have a nice weekend and stay warm. Yeah. Put a blanket over your favorite plants too, because otherwise they'll be frozen. I don't have plants. You don't have plants. Faucets, okay, spigots, outside, anything that has water.
I have a quick question.
Right.
At Folsom Lake, the only class they have for CISP 360 is online.